my name is Nils, and besides working at Neptune, I'm also a grad student in Germany focusing on machine learning, statistics, and everything that comes with it. When I'm not sitting in front of a desk, you will usually find me in a glider cockpit, like you can see on this picture here. You now might ask yourself, what does gliding have to do with machine learning? It's not really obvious. Well, in gliding, you constantly do two things. First and foremost, risk management, because you want to land safely again, right? You don't want to fall from the sky. Second of all, you want to optimize every step and every decision you're doing, because you want to be the fastest. And I hope at the end of these 10, 15 minutes, it will be clear where the connection between gliding and machine learning lies. Okay, so I want to start with a tweet by Elon Musk. This is now 5 years ago. And he tweeted, "We need to be super careful with AI. It's potentially more dangerous than nukes." Now, I would like to ask all of you who agrees with Elon Musk. Just please raise your hand. This is about half, maybe. Who does not agree? Who doesn't know? One last question. What is AI? Who could explain me right now what AI is? You don't have to. Just single hand, maybe two. All right, 2, 3 people, right? And I think this is the problem with tweets like that or headlines in the newspaper. They scare people a bit. People are unsure how AI works, what it is. And exactly because of that reason, before I'm going to talk about what Neptune does with machine learning, I will like to give you all an intuition on how it works and why we actually need it. So AI, right? We all heard it. What is it? AI is a concept. It's not tangible. There's not really a definition. And right now, everything that's called AI in blogs or newspapers is actually machine learning. And machine learning is very tangible. Machine learning is a set of algorithms, math, statistics, computer science. And a subclass of these machine learning algorithms are artificial neural networks. And they're called that way because they're trying to mimic the brain in their structure. And now, maybe some of you heard of deep learning. And deep learning are basically just more complex neural networks, which actually work quite well in advanced topics, like, for example, self-driving cars, or the chess computer that bet the world championship. But why do we need it? Well, we all know that data is increasing in huge amounts, right? Just to give you one example, each year, roughly 200 billion tweets are produced by every one of us. If one person analyzed 7 tweets a minute, it would take this person 21,000 years to analyze all these tweets just for 1 year. If you paid him $10, it would cost you $5 billion. Now, he won't do it for $10. You don't want to spend $5 billion, and you most certainly don't want to wait 21,000 years. Machine learning is the answer. Machine learning analyzes data very, very fast, much faster than we humans do. So we talked about the what, we talked about why we need it, how do they actually learn? And for that, I want to take you and your maybe imaginary 2-year-old kid on a safari. And on this safari, you drive by a bunch of elephants. And this kid asks you, "Mom, Dad, is that a cat?" You're a bit surprised, I get it. But you explain to the kid, all right, I mean, it has a trunk, it has big ears, a cat has fur, it's much smaller, it's not a cat. Kid knows, all right, elephant, not a cat. Drive a bit further and you see someone learned already, right? You see a tiger, which is technically a cat. So, but the kid asks again, is that a cat? And you respond, well, you're closer. Technically, yeah, but you know, we call this a tiger. It's still much bigger than a cat. Back home, your neighbor has a new cat, and it strolls around in your garden, and the kid sees it, and asks you again, "Mom, Dad, is that a cat?" And this time, yes, son, daughter, whatever, this is a cat. Now, the kid learned that this is a cat, that the previous picture was a tiger, and the first one was an elephant. Machine learning algorithms basically learn the same way. What they don't know is that the first one is an elephant, the second one is a tiger, and the third one is a cat. It only knows cat or no cat, right? So it only can do what you train it to do. So you don't really have to be afraid of it taking over the world unless someone is training it to take over the world, right? All right, I hope an intuition is built. So how can we as Neptune use this in our platform? And there are actually quite a few possibilities we can do. One is code assistance. Think of this like the old paper clippy in Microsoft Word versions, which basically suggests you, all right, please use function A instead of function B because it's much more efficient. Another thing is sketch to code. In sketch to code, we imagine as you drawing an app on a piece of paper, load it into our platform, and have the app built ready. Easy. A third thing, and this is what we're going to talk about today, is code prediction. Code prediction is not code completion. Code completion is IntelliSense, right? We all know that. Code prediction starts before you even type something. It won't just finish the next word. It will also predict the next block of code. How does it work? Well, everything that has been written so far gets funneled into this machine learning algorithm. We also call these algorithms model. And the model will suggest the user, developer, 3 possible suggestions. Now, the developer can either accept one of them, says, all right, cool, I want that, or just ignore it. So by using this, no disadvantage will be there, right? It only can be better. Now, we said earlier, machine learning algorithms, models need examples. Luckily, there's a freely available dataset which contains 150,000 JavaScript files. Now, the problem is this is raw data. Something is maybe written in Chinese, right? And we don't really want that. Another question you might have to ask yourself is, do you want to analyze the comments that are within the code? Do you want to leave them out? After cleaning, we roughly extracted 250 million words. This is about as much as a person writing 10 emails a day for 500 years. So it's quite a lot. After you cleaned and pre-processed your data, you built the models. And we didn't only build one model, we built multiple models to capture different aspects of the code, different information. Once you build the model, you train and test. Train and testing is quite easy, right? The model does that basically for you. The hard part is the pre-processing and the architecture. The cool thing is, the developer that uses our platform will have nothing to do with that. This is being deployed with our platform. It will work online, offline. We will not look at your code. It will all stay on your side. It just works. Now, a cool side effect of predicting code is that the model can generate code. An example. This is something I just fed the model, so it has some context. The model came up with that. Now, you can see the model learned formatting. It refers to parameters, and it's syntactically correct. Now, this has today not really used because, yeah, right? This is future. And in the future, we imagine to have the model write the code for you. Let's wait 5-10 years and see, right? But let's see what we can do today. This is the editor we are using in all of our platforms when we're coding JavaScript. And let's say we want to write a function. Function is being suggested because we have nothing written so far, so we use that. With our snippets, you can just press tab each time you want to navigate from function name to parameter list to body. Now we want to declare a variable. The variable is called nep. Let is fine, by the way, that's cool. And nep is a string, relax. Now we want to declare a second variable. And you can already see that the suggestions change depending where you are in the code. Another variable I said, we call it other, and a string keep manual coding. Now we want an if-else block. It is again suggested, so we use it. We type in the condition, and now we want to return the variable nap. Let's check what the suggestion says, and return is suggested. Very good, so we return nap, and else we return other. Press again tab, function is written, easy as that. Now we want to call the function. And now you can see expression statement is predicted, but this model, because we train multiple models, cannot capture the name or the type of expression. Expression statement, you have to think of something like everything you can, well, express. So we just ignore what the model suggested us and type it for ourselves. Easy. Recap. The code prediction and all the future machine learning projects within Neptune will definitely lead to faster results because coding will be much easier. There will be less risk because you use the snippets and the snippets don't have errors. And you have more standardization within your company because everybody's using the same snippets, right? If you have any questions about machine learning, if you have concerns about machine learning, if you don't, well, agree with anything I said, please approach me. I'm here all day or in the booth. I'm happy to answer all of your questions. Even, if someone wants to know more about gliding, that's cool. I started with a tweet about AI. I want to finish with one. Matt Veloso wrote, the difference between machine learning and AI is, if it's written in Python, which is a language for those who don't know, it's probably machine learning. If it's written in PowerPoint, well, then it's probably AI. Thank you.